Good morning. We will continue the properties of pure substance prepared by Dr.M.EZHILAN, Professor, Department of Mechanical Engineering, Rovani College of Engineering and Technology. Ideal gas law. Robert Boyce formulated a well-known law that states the pressure of a gas expanding at constant temperature varies inversely to the volume. So P1 V1 equal to P2 V2 equal to constant. As a result of experimentation, Charles concluded that the pressure of a gas varies directly with the temperature when the volume is held constant, and the volume varies directly with temperature when the pressure is held constant. V1 divided by V2 equal to T1 divided by T2, or P1 divided by P2 equal to T1 divided by T2. By combining the result of Charles and Boyce experiments, the following relationship can be obtained. PV divided by T equal to constant. The constant in the above equation is called as ideal gas constant and is designated by R. Thus, the ideal gas equation becomes PV equal to RT or PV equal to MRT. In order to make the equation applicable to the all ideal gas, universal gas constant R equal to RU divided by M, molecular weight. For example of the ideal gas constant for air, air equal to RU, air divided by M air, equal to 8 point universal constant value is 8.31444. The molecular weight of air 28.96. The value is 0.2871 kilojoule per kg Kelvin. The amount of energy needed to raise the temperature of the unit of mass of substance by 1 degree is called a specific heat constant volume. That means CV for a constant volume process and the specific heat at constant pressure. CP for the constant pressure process. They are defined as CV equal to delta U by delta T in suffix V, and CP equal to delta H divided by delta T in suffix P. Using the definition of enthalpy H equal to U plus PV and writing the differential of enthalpy relation between the specific heats of for ideal gases, H equal to U plus PV, delta H equal to du plus RT, Cp dt equal to Cv dt plus R dt, Cp equal to Cv plus R. The specific heat ratio K is defined K equal to Cp by Cv. For ideal gases, internal energy, enthalpy, specific volume and specific heat function of temperature around the delta U and delta H ideal gases can be expressed as delta U equal to U2 minus U1, that is Cv into T2 minus T1. Delta H equal to H2 minus H1, that is Cp into T2 minus T1. Simple Rankine cycle diagram and TV diagram. The main components of the steam power plants are boiler, turbine, condenser, cooling tower, pump. From graph, first 1 to 2 is a isentropic process, 2 to 3 is a isobaric process, 3 to 4 is a isentropic process, again 4 to 1 is a isobaric process. Boiler is used to produce a steam. Heat energy produced by coal is used to produce steam. Water is allowed to heat until it becomes into vapor state. Vapor is sent into the turbine. Turbine produces the work. Work produced used to run a generator. The enthalpies at the enter and exit of the turbine are different. The vapor is sent into the condenser. The condenser of the main function is the vapor is condensed to water into the condenser and sent to the pump. The pump is sent to the water again to the boiler, and the cycle is repeats again. Steam turbine, W turbine equal to H1 minus H2, condenser Q, heat is rejected, H2 minus H3, pump H4 minus H3, boiler, heat is added, H1 minus H2, H4. Turbine produce more work if the water is heated to superheated region. If the water is heated to superheated, then the turbine will produce the more work. But there is a problem if water heated to superheated. When it is condensed, the vapor is not converted into water completely. It remains still as a mixture. It is difficult for the pump to handle both liquid and water, which leads to cavitation. Thank you.